So in the second video on inequalities, I'm going to show you how to solve inequalities. It's important that if you haven't already, you watch the previous videos I made on solving equations and solving two-step equations, as well as the last video we looked at where we showed how to display inequalities on a number line like this. Okay. Solving inequalities is very similar to solving equations. Okay, so basically if I was to look at this first example where I have x minus 3 is greater than or equal to 2, I have been asked to solve it, as in get x on its own and then display it on the number line provided. So just like an equation, if I want to get x on its own, what I have to do is I have to treat the inequality like a set of scales, okay, that are continuously balanced. And if I'm looking to get x on its own, what I have to do is, because this is a minus 3, I have to add 3, because minus 3 plus 3 is 0. But if I do that, the scales will become unbalanced, so I must do the same to the right hand side. Treat the inequality just like the middle of the set of scales, and again, just like the way we would solve an equation. So what happens there is I've still got x, minus 3 plus 3 is 0, so it's gone. It's greater than or equal to 5. And then I have to show that on a number line. So what I do is I draw a dot above 5 on the number line, and because it can be equal to it, again this is in the last video, I make sure it is a closed dot and my arrow goes to the right, just like this. Okay? And that's how we would solve an inequality and show it on a number line. The next one, and again, why it's important to watch our video on solving equations. This is kind of like a two-step equation, but just keep in mind these aren't equations because there's no equals, it's an inequality symbol. I have to get x on its own, so I have to get rid of the 2 and 3. So I'm working backwards, so I'm going to get rid of the plus 3 first, so I have to subtract 3. But again, to keep the inequality balanced, I have to subtract 3 from the right hand side as well. So I'm left with 2x plus 3 minus 3 is 0, so it's gone, is less than 15 take away 3, which is 12. And now to get rid of the 2, just keeping in mind what the 2 is doing with the x, the 2 is multiplying. So to get rid of 2 multiplied, do the opposite, which is divide. So I divide by 2, but remember I have to do the same on the right hand side as well. So I'm left with x, 2 divided by 2 is 1x, which is just x, is less than 6. And then we mark that on our number line by doing an open dot, because it cannot be equal to it, with an arrow going to the left. Okay, the arrow on the number line just goes, and again I pointed this out in the last video, the same direction as the inequality itself is pointing. Alright, I'll do one more example, and I will make sure in a follow-up video to look at harder examples of these where we have this type of inequality, and again I showed this to you in the last video. What I'm looking to do is get x on its own in the middle of these two inequalities. Okay, so I need to get rid of the 2 and the minus 1, and again similarly working backwards, I have to get rid of the minus 1 first. To get rid of the minus 1, I have plus 1. Okay, I mean if I was to ignore that side just for a minute and I just treat it as if it was 2x minus 1 is less than 4, I would just be adding 1 to this side as well. But because we also have that side, I have to add 1 over here as well. Okay, so we're just adding 1. Whatever we're trying to get rid of in the middle, we'll make sure we're doing to both these sides as well. So minus 3 plus 1 is minus 2. It's less than or equal to 2x. Minus 1 plus 1 is 0, so it's gone. 2x plus 1 is 5. And then the last thing I need to do is I need to get rid of this 2 in the middle. So because this 2 is multiplying with the x, I simply divide by 2. But again, I have to make sure I divide by 2 over here and divide by 2 over here as well. So whatever I'm doing to the middle, I do to either side of the inequalities as well. Alright, so minus 2 divided by 2 is minus 1, less than or equal to 2x divided by 2 is 1x, which is just x, less than 5 divided by 2, which is 2.5. Okay, and I will show that. So this is telling me that my values of x are between minus 1 and 2.5. So I'm doing a dot above minus 1 and a dot above 2.5, which is obviously between 2 and 3 here. And the closed dot again is just wherever it can be equal to it, like we did over here. So this will be our closed dot above the minus 1. And this is telling me my values of x are between minus 1 and 2.5, so I connect them. Now, quite often a follow-up question to this type of one is, what are the possible integer values of x? Okay, and just to keep in mind, an integer is a whole number, so what are the possible whole numbers that x could be? Well, minus 1, 0, 1, 2, and 3 we will look at, okay? So minus 1, because x can be equal to it, so my integer values will consist of minus 1, 0, 1, and 2. And if you're querying, well, could it be 3? We'll know 3 lies outside of 3 is greater than 2.5, whereas we know x has to be less than 2.5. Okay, so just keep in mind if it ever asks you for the integer values with this type of inequality, you're looking at the whole numbers that x could possibly be. I'll post some questions for you to try, and anything you're unsure about, just ask.